in this class is for basically student of class 9, and today I am going to discuss about expansion. Okay, your algebra chapter expansion, the chapter expansion. Okay, actually this chapter I taught you in class 8. Okay, and this chapter name was, I think, Identities. Okay, expansion, this name comes from the expanded form. Okay, so first question arises, how to expand. Okay, and expand totally follows from distributive property. So first you have to learn about distributive property. I am discussing all these things for remind the previous class or previous knowledge, so that you can remind the concept of class 8. Okay, so what is distributive property? Actually distributive property was one two fundamental operations, multiplication and addition or subtraction. Suppose we have a dot b plus c, then this is the factorized form, and we can expand it since a is multiplicative form with whole this first bracket, so we can expand this a with first b and henceforth with c, and ultimately we will get a into b plus a into c. A into b means in algebra AB, and this is AC. Actually this is called distributive property, and you know very well, I think. Okay, so on the basis of this property is called distributive property. Distributive property. Okay, so on the basis, based on this property, we'll expand to algebraic expression, multiplication form of to algebraic expression. Suppose I am considering an example that expand 2x into 5x minus 3. Then easily all of you are able to expand it. How? First multiply by these two, then first multiply the integer part, then 2x is there and this is 5x. So if you multiply the integer part, then 2 into 5 is 10, and the algebraic part, x into x means x is square, minus is there, so minus 2x into 3 means 3 to the 6x. So this complete the expanded. So this is the expanded form. Okay, sometimes we have used the distributive property repeated times to expand in some problems. I am discussing that type of problem once. Just suppose I am telling you for expand this part, expand a plus 2b into x plus a. Then easily you can expand it. How? First this first one we have to multiply entire, then a into x plus a. After that this to this, and next 2b with whole. Okay, so plus is there, so plus 2b into x plus a. Okay, so it is ax single x distributive property plus a square plus 2bx plus 2ba. So this is the expanded form. Hope I know that all of you are able to expand this kind of problem, and you have solved this type of problem various times. Okay, now suppose I am giving you a very easy problem that expand a plus b into a plus b. Okay, so how to expand this? Expand it, then a into a plus b. First this with whole this part and plus is there, b into whole this part, a plus b. Now multiply, then a square plus ab plus ba plus b square. So ultimately we get a square plus ab. In the place of ab and ba, these two are same thing, so we can write ab plus b square thing. So in the place of ab, ba, we can write ab plus b square. After simplifying, it will be a square plus ab, these two like terms, so this will be 2ab plus b square. So this is the simplified form or expanded form of a plus b into a plus b. Okay, just remind one thing again, that what do you mean by 2 square? 2 square means 2 into 2. Okay, what was the meaning of 5 to the power 3? That was 5 cube. That was 5 into 5 into 5. So if you multiply a number repeated times, then we can express that number into the form of exponent. Okay, this is called exponent. So this is a plus b. We have multiplied here a plus b into a plus b. So in the place of this, we can write a plus b whole square. So a plus, in the place of this, we can write a plus b whole square. Right? In the place of these two, you can write a plus b whole square. So ultimately a plus b whole square means a plus b into a plus b. After that, the last line is this. So we get the result that a plus b whole square equals to a square plus 2ab plus b square. So this is the expanded form of a plus b whole square. Now, so many teachers says that this is a formula, but basically this is not a formula. This is identity. This is called identities. Okay, and we have to memorize this line, that a plus b whole square equals to a square plus 2ab plus b square. Now question arises that why we have to memorize it. Actually, basically this was a question. I have given you that expand it. This was the question and answer is this. So you have to memorize the question and the corresponding answer. Okay. So question arises, why you have to memorize this part, that a plus b whole square equals to a square plus 2a plus b square. We have to memorize it for our benefit. Suppose if I am asking you that what is 7 into 8, then easily you will give me the answer. Let's say 7 into 8 means 56. Okay, but if I am asking, suppose if I ask you that 30 into 17, then you are unable to give the answer. Why? Since you have not memorized this part. Okay, so we have to memorize this for our benefit. Clear? So this is one observation, that a plus b whole square equals to a square plus 2ab plus b square. If you write this line in this way, that a square plus 2ab plus b square equals to a plus b whole square. Now simplify from this line, find the value of a square plus b square from this line. So if you try to find out the value of a square plus b square, then a square, this term, and b square we keep in this left hand side, and all the terms move to right hand side. Then this will be a plus b whole square already was there, and if we consider this term 2ab into the right hand side, then this will be minus 2ab. So we get one more result, that a square plus b square equals to a plus b whole square minus 2ab. Okay, so now we have two results and we have to memorize these two results. What result is for a plus b whole square equals to a square plus 2ab plus b square, and second one, a square plus b square equals to a plus b whole square minus 2ab. You have to note down all this information by pause the video. Okay. Next, I am giving you one more question, that a minus b into a minus b. This is the question, and solution easily you can solve, that a minus b into a minus b equals to a square minus ab minus ba plus b square. So ultimately we get a square minus 2ab similar way plus b square. So a minus b into a minus b, in the place of a minus b into a minus b means what? Actually entirely this is nothing but a minus b whole square. So ultimately a minus b, after expanding a minus b, we get this line. So we have to memorize this question and answer. Okay, so ultimately we get one more result, that a minus b whole square equals to a square minus 2ab plus b square. This again similarly we will simplify from this line. Just I'm writing it again, that a square minus 2ab plus b square. In backward direction, this is equals to all this line. This line is equals to this line. This line is equals to this line. So this line equals to obviously this line. So this equals to a minus b whole square. Okay. Now if we calculate the value of a square plus b square from this line, then it will be, we are keeping here a square plus b square, and we forward this term 2ab to that side. So it will be a minus b whole square plus 2ab. Okay, so this is one more result. So write it, that again we get a square plus b square equals to a minus b whole square plus 2ab. Okay, a plus b whole square equals to a square plus 2ab plus b square, and a square plus b square equals to a plus b whole square minus 2ab. A minus b whole square equals to a square minus 2ab plus b square, and a square plus b square equals to a minus b whole square plus 2ab. So we have to memorize all these four. How to memorize these two? There is a very easy process. Okay, just listen. See, in the case of plus a plus b whole square, a square plus 2ab plus b square. Just write for a minus b identities. It will be a square. Since there is minus, in the case of plus it was plus, and this minus, it will be minus 2ab plus b square. And for a square plus b square, we have two identities. One is for a plus b whole square minus 2ab, and another one is a minus b whole square plus 2ab. These two. Now, one question can arise in your mind, that which one we will use, when we will use the first one and when we will use the second one. Actually that depends on the questions. Okay, I am discussing some example, then it will be clear that when you have to use the first one, when you have to use the second one. I am considering some example. Okay, this complete the concept of first chapter. If a plus 1 by a equals to 3 is given and you have to find out a square plus 1 by square, so many processes are there to solve it. See, if we take 1 by a as b, then a plus b is given and you have to find out a square plus b square. So the answer of first one, a square plus 1 by a square, this can be written as a square plus 1 by a, the entire whole square. Now if we use a square plus b square, then a square plus b square having two properties. One is a plus b whole square minus 2ab, and another one is a minus b whole square plus 2ab. Here this is a, this is b, then a plus b we need. A plus b is given, so we have to use this one. So what is the rule? That a plus b, that is 1 by a whole square minus 2ab. This cancel out. Put the values. A plus 1 by a equals to 3 square minus 2. 3 square means 9 minus 2 equals to 7. This complete the first solution. Okay. And for the second solution, for the second one, I am solving here. I am solving here the second problem, that a to the power 4 plus 1 by a to the power 4. This can be written as a square the whole square plus 1 by a square the whole square. Again a square plus b square. This one is a, this one is b. So now we have a square plus 1 by a square, already we have this value, so we can use it. So a square, this is a plus b whole square minus 2ab. 2ab means a square into 1 by a square. This cancel out. We have the value of this one, a square plus b square, the first 7. So put here 7 square minus 2. 7 square means 49 minus 2 equals to 47. This complete the solution. Next, we have to simplify the value of a plus b plus c the whole square. Okay, that means expand it. This is the question. Expand a plus b plus c whole square. The solution is a plus b plus c whole square. This can be written as, you can solve it, you can expand it by a plus b plus c into a plus b plus c. Okay, but I am using another way. I will use this concept. So first make the group, then a plus b plus c the whole square. Just we are making the group. We have made here the group a plus b into a same group. If we remove the bracket, then it will become same. So if we consider this as a, then first plus second, then first plus second is first square plus 2 into first into second plus second square, b square. So it will be a plus b whole square plus 2 into first into second. That means a plus b into c plus second square. Actually I have used this one. Now we know, we have already memorized the expanded form of a plus b square. Did you get it? Now you realize where is the advantage of memorizing a plus b whole square. A plus b whole square into a plus b into a plus b, we will not do that. Directly we will write the answer. A plus b whole square, because we have already memorized it. It will be a square plus 2ab plus b square. This is the advantage of memorized. And this is nothing but 2c into a plus b plus c square. Now simplify more, then a square plus 2ab plus b square plus 2ac plus 2bc plus c square. Now just arrange all the data. A square plus b square plus c square. Just I am considering this one and this one, and write all the other terms. 2ab plus 2bc plus 2ac. This. So this is the expanded form of a plus b plus c whole square. So we have to memorize this also, that a plus b plus c the whole square equals to a square, where we have given square in all the terms inside the bracket. C, a square b square c square, a square b square c square plus 2ab, 2 into first second, second third, first third. So plus 2ab plus 2bc plus 2ac. Understood? So a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Okay, so you have to memorize this result, that a plus b plus c. Right now, note down this part, that a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Okay, so you have to memorize this one also. And for a plus b minus c, then easily you can write this expanded form. In the place of, if a plus b minus c is there, then you can write. How? Just when you multiply a first and second, see the sign. Okay, I am giving you. Suppose we are going to find out the expanded form of a minus b plus c. Okay, what is the identities for a minus b plus c? A minus b plus c whole square, just this one. Give individual square, a square plus b square, this is always plus, okay, plus c square. There will be, if we consider first and second, first one is positive, second one is negative, so plus into minus will be minus, so this is 2ab. And when we consider first, second, third, second is negative, third is positive, so plus into minus, again minus, 2bc. And first, last, first is positive, last is positive, so 2ac. So this is the formula, easily. You no need to memorize this part. Okay, just wait for a minus b minus c whole square, write it. It will be a square plus b square plus c square. This is always fixed, okay, a square plus b square minus. Here first one is positive, this is negative, so plus into minus, minus 2ab. When we will write bc, then b negative, c negative, so negative into negative, positive, so 2bc. And when first and last, first is positive, last is negative, so plus minus minus 2ac. Understood how to expand this whole square of 3 terms? This is very simple. Clear? So this is one more identities which you have to memorize. Okay, I am writing in right hand side of my board all the identities which we have to memorize. Okay, one more identities we have, that a plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Now we will derive some important result. Okay, say important result. Suppose I have a plus b whole square, and we have to convert this a plus b with the help of a minus b, that means in terms of a minus b. The target is clear. We have to convert this a plus b whole square into the form of a minus b and ab. How is it possible? See, a plus b whole square equals to a square plus 2ab plus b square. We know this result. Now we have to make here a minus b. So to make here a minus b, we know that a minus b square equals to a square minus 2ab plus b square. So in the place of plus 2ab, if we have minus 2ab in this place, then easily we get a minus b. Okay, so by force we will consider this 2ab plus b square. Then this line and this line are not identical right now, these two lines. Okay, this line and this line are not identical. This term comes extra. Suppose I am writing here 2ab, then this term is extra. See, a square plus b square plus 2ab, a square plus b square plus 2ab. So minus 2ab is extra, so we have to balance it. We have considered here minus 2ab, so if we balance it, then plus 2ab, then plus 2ab and minus 2ab will be cancelled out, this, and ultimately this line and this line become identical. Understood? Just we have considered this term a minus b. This is very important part. Just to convert into the form a minus b, we have considered minus 2ab. So up to this term, this is a minus b whole square, and if we simplify these two, then this is 4ab. So this is also important result, that a plus b whole square after simplified, or if we expressed a plus b whole square in terms of a minus b, then we will get a minus b whole square plus 2ab. So this is one more result, and which you have to memorize, that a plus b whole square equals to a minus b whole square plus 4ab. Okay. Similarly, if we consider this 4ab term into this side, then again we get a minus b whole square this side equals to a plus b whole square minus 4ab. So this is the all identities for the first chapter, and you have to memorize all these identities thoroughly. Then each and every problem of this chapter you are able to solve. Understood? Otherwise you are unable to solve. Very simple. You have to memorize this. Okay, these are the not formulas, actually these are the identities, and we have to memorize for our benefit only. Is that clear? Okay, in my next video I will discuss about the application of these identities. Okay, I will discuss all the application of these identities. Okay, thank you.
Please subscribe my YouTube channel and press the bell icon so that you get the notification of all updates.